attempting to simulate the conditions caused by giant rogue waves.
Well, we're basically testing what would happen if a large rogue wave came up on this vessel while they were loading the fish on. And basically this is a situation where they typically will have a hatch open and they'll be loading the fish in. And if a large wave came at that time, you could fill the boat with water and it could sink it.
The results are simple and dramatic. It only takes a few waves to overwhelm the model.
When you see it sinking, you see what that time scale is going to be. It's going to be pretty quick.
If surprised by a rogue wave, the Marian Anne could have sunk in seconds with no time to send a distress signal. It seems a plausible theory, but without finding the boat, it's impossible to prove. Refusing to give up, the Coast Guard launched another search for the Marian Anne, with help from the US Navy.
The Coast Guard contacted the Navy. They came up and conducted what they call a side scan sonar search of the bottom in the general area in which the fishing vessel was believed to have sank. They developed basically a 20 square mile box in which they forecasted that the vessel most likely would sink if it actually sank at the time that they stopped broadcasting. They searched that 20-mile square box for basically 3 days.
After an exhausting search, 3 months after it disappeared, the Marian Anne was found, 642 meters underwater. Using a submersible equipped with an underwater camera, the Coast Guard made a shocking discovery. The ship was perfectly intact, with no signs of damage.
The vessel is sitting upright on the bottom. There's no clear indication of any type of a collision. Unfortunately, after viewing the video, it basically didn't help us determine the actual cause of what's caused the vessel to sink.
This disturbing discovery created more questions than answers. What could be powerful enough to sink a ship fast enough to surprise the crew and leave no damage? To solve this mystery, investigators needed more clues. Going back to the video, closer examination revealed that the Marian Anne's nets were almost fully retracted.
We were able to locate the fishing net. It's, for the most part, hauled up on the wheel.
Investigators theorized because the nets were up, the boat was loaded with fish and may have become unstable.
One of the issues that we've seen in other vessels or other casualties is sometimes the question of whether or not the product on board, if it's not properly segregated, can shift as the vessel deals with the weather, and that can cause stability issues.
To keep a boat stable, distributing the catch evenly in the cargo hold is vital. Unbalanced, a vessel can roll too far and rapidly take on water. If this happened to the Marian Anne, it might explain why no distress signal was sent and why there was little visible damage to the ship. Investigators closely examined the video to see if this was the reason why the boat sunk.
In this particular case, we weren't able to see inside the fish hold, so we couldn't make any type of determination.
Due to the extreme depth, divers were unable to examine inside the boat, so the investigation hit another dead end. But a bizarre new theory emerged. Could the Marian Anne have been sunk by volatile, highly destructive methane gas bubbles? In 1985, a cameraman captured footage of a drilling platform in the North Sea being destabilized by methane gas bubbles from the ocean bed. Dr. David Vakari at the Center for Maritime Systems in New Jersey believes this phenomenon could, theoretically, have overwhelmed the Marian Anne.
Methane is formed in the sediments by biological processes. Bacteria, in the absence of oxygen, will undergo a fermentation process and produce the methane. First it's going to be dissolved in the water. As it builds up, the water can't hold anymore and it essentially breaks out into bubbles. Sort of like when you take a bottle of soda water and you take the cap off, you have carbon dioxide dissolved in that water. But when you release the pressure, that carbon dioxide comes out of solution and forms the bubbles.
Methane gas is buried beneath the ocean floor, in frozen deposits called methane hydrates. They release bubbles when exposed to warming seas, earthquakes, or landslides.
If a swarm of small bubbles rose under the ship, it would decrease the density of the water the ship was floating in. The ship would then settle down into the water, possibly enough to cause it to swamp by the water coming over the side of the ship directly.
To test this theory, researchers placed a boat in water and laid a system of pipes on the seabed beneath it. Air pumped through the pipes simulates methane gas, creating bubbles that float to the surface, with dramatic results.
It's possible for bubbles to sink a ship. Is it likely? That I would need more evidence to support the likelihood.
Despite 6 years of investigation, theories, and speculation, the definitive cause of the Marian Anne's tragic sinking has yet to be resolved. But in Humboldt Bay, the Marian Anne and its crew have not been forgotten.
It's not that distant. It's still very new and fresh, and still a very big mystery. And no closure. Still have no idea what happened. And that's very hard.
With no answer to the mystery, the US Coast Guard has finally closed the case. So for now, this is one mystery that cannot be explained. Boats are sinking, and nobody knows why. Is that weird, or what? Scientists often say we know more about the moon than we do about the Earth's oceans. There's little doubt that many strange phenomena are yet to be discovered. In 1997, something emerged from the ocean that has confounded scientists to this day.
Should I say, wow, what is that? We're still trying to figure it out.
I mean, I still get asked all the time, well, what is it?
I still don't know what it is, and I still don't have any good ideas about what it might be.
From deep within the Pacific Ocean came one of the loudest and most mysterious sounds ever recorded in the natural world. Was it a volcano? A whale? A sea monster? So far, no one knows. During the Cold War, the US Navy implemented a sophisticated underwater listening grid to monitor Soviet submarine activity in the Pacific. In 1991, with the Cold War over, the Navy contacted oceanographer Christopher Fox and offered to give him the system for use in environmental research.
There was an effort in the United States to see if we could take military systems and use them for environmental science.
Fox and his team utilized the Navy's network of hydrophones, or underwater microphones. Over the years, the Navy placed hundreds of them around the world's oceans. For the first time, scientists have the means to listen in to large areas of the deep sea.
We began hearing whales. Of course, we heard shipping and man-made sounds.
But as they listened to the multitude of ocean noises, one sound stood out from the rest.
We heard it, and then we probably played it back several times because it was very unusual.
The reason they took notice was the volume. At 180 decibels, it was so loud it was picked up by 2 hydrophones over 4. Geological, a secret military test, or something beyond our comprehension.
I think it's exciting to think that there are things going on in the ocean that we don't know what they are.
If it was biological, it raises an intriguing question. What creature produces a sound that could travel such a distance?
Yeah, it really is hard to say what kind of creature could it possibly be.
To produce this powerful sound, the animal would have to be enormous. Blue whales are the largest creatures on Earth, over 30 meters in length and weighing an estimated 130,000 kilos. Could a blue whale be the answer to this mystery? David Mellinger is a marine biologist. He's analyzed the bloop to see if it matched any known biological sound.
Blue whales are extremely loud, there's no doubt about that. Something you can hear tens of, or maybe hundreds of miles away has got to be really loud. See, I could put them side by side. Here's the blue whale sound. And this one here is the bloop sound. Blue whales are, even though